Okay, so at the end of class, we were starting to talk about how the sine and cosine functions, the trig functions, are functions that are cyclic. That means that they just keep going through the same values over and over again. And so we can use these functions to represent things in the real world that we can't use any of the other functions for that we've learned about, things that are cyclic. So the orbit of planets, the things like sound waves that are cyclic, lots of different real life things are cyclic. They just keep going over and over again. The seasons, weather, all kinds of things that just have the same values over and over. And we need a mathematical model for those things so that we can investigate them with math. Sine and cosine are great for those kinds of situations. So you can see all these values that we have on the x-axis here. They're all angles. And you can see that we have values for cosine for all those angles, even angles bigger than 90, angles less than 0. So far, all we've been using to find cosine and sine are triangles, where the angles inside the triangle are acute, and the definitions of cosine and sine, opposite over adjacent, opposite over hypotenuse, I mean, those all make sense because it's a triangle, and you're in there, and you know what side is opposite, what side is adjacent. But now you're talking about angles that can't fit in a triangle. I mean, 270 degrees is not an angle inside a triangle. So how do you find the sine, cosine, etc. of those things? And that's what we're getting ready to talk about. And the way that we deal with that situation is that we take this x-axis with either radians or degrees on it, like in this picture, and we wrap it around a circle, and then we create triangles that are related to the angles we're trying to find the sine or cosine or tangent of. It will remind you a lot of polar coordinates because it's basically the same idea. But we'll go ahead and go through an example, and I think it'll make sense. So if we let the point P be -2, -5, so this point in the third quadrant, and we let it be a point on the terminal side of an angle theta drawn in standard position. So remember, an angle in standard position has its initial side on the positive x-axis, and then you rotate around in the counterclockwise direction until you get to the terminal side, which in this case they say they want the terminal side to go through the point -2, -5, and that's what we have here. So we have this angle, it's obtuse, obviously can't fit in a triangle, but we can draw a triangle, and so we do that by dropping an altitude to the x-axis. When we do that, the horizontal side of the triangle is the x-coordinate, and the vertical side of the triangle is the y-coordinate of this point, -2, -5. We can work with a triangle like that where we know the sides, got the legs, they are x and y, and then we can find the hypotenuse. And the angle that we call the reference angle for the angle theta, we call it theta prime, which is just theta with a little apostrophe next to it. It's the acute angle between the terminal side and the x-axis. And that angle, we will use that to find the sine, cosine, and tangent and the reciprocal functions for theta, our big angle that is something between 180 and 270 since it's in the third quadrant. And basically, all we have to do is solve the triangle, find the sine, cosine, and tangent for theta prime, and then we just have to apply the fact that we're in the third quadrant where x is negative and y is negative, and we have to apply those signs to the 5 and the 2 in the ratios we get. So just remembering, we have 4 quadrants, so this is quadrant 1. In quadrant 1, x and y are both positive. In quadrant 2, x is negative and y is positive because you have to go to the left and up to get to these points. In quadrant 3, x is negative and y is negative because you have to go left and down to get to that quadrant. And then in quadrant 4, x is positive and y is negative. So if we keep those things in mind, all we have to do to find the trig functions for any angle, no matter how big or small, we just rotate around the circle till we get to the angle we're talking about. We figure out which quadrant we're in, and then we just use the triangle that has the angle between the terminal side and the x-axis solve that triangle, find sine, cosine, and tangent in that triangle, and then just make sure to put the correct sign, meaning positive or negative, on the adjacent side or the opposite side as we write the ratios for the trig functions. The value of the hypotenuse will always be positive. I'm just going to go ahead and remove the triangle from the graph just so we can see it better. And then the first thing we're going to do is find the hypotenuse using the Pythagorean theorem. So 5 squared, if we call the hypotenuse h, we'll have 5 squared plus 2 squared equals h squared. So that's 25 plus 4 equals 29. So h is going to be the square root of 29. So now we have all our sides. We just have to find sine, cosine, and tangent for theta prime. So sine of theta prime is equal to opposite over hypotenuse. So that's going to be 5 over the square root of 29. And I'm not going to rationalize that just yet because I'm not done with the problem. Cosine theta prime is adjacent over hypotenuse. So that's 2 over the square root of 29. Tangent theta prime is equal to opposite over adjacent. So that's 5 over 2. So those are the trig functions for theta prime, the little angle, the acute angle in the triangle. And now all we have to do to write the trig functions for sine theta is just make the 5s and 2s negative because in the third quadrant they are. So sine of theta, just plain old theta, which is the angle between 180 and 270 that we've been talking about, would be negative 5 over the square root of 29, which, if I rationalize it, is negative 5 square root of 29 over 29. Cosine theta, instead of being 2 over the square root of 29, it's going to be negative 2 over the square root of 29, which is just negative 2 square root of 29 over 29. And then tangent theta is going to be just like tangent theta prime, except that now the 5 and the 2 are negative. And actually that ends up being positive again. So tangent is positive in the third quadrant. And that's what I want to write right now is what you can be sure of about any angle that ends up, that its terminal side is in the third quadrant. Sine of theta, whenever theta is in the third quadrant, is always going to be negative because the opposite side to theta is always negative. And the hypotenuse is positive, so you end up with a negative. Cosine theta in the third quadrant, for any angle that ends up in the third quadrant, will also be negative because the x-coordinate is your adjacent side, and it's always negative in the third quadrant. So negative over the hypotenuse, which is positive, is going to be negative. And then tangent theta in the third quadrant ends up being positive because both the opposite side and the adjacent side in the third quadrant are negative, and therefore negative over negative gives you a positive. So you can be sure, no matter what, if your angle has its terminal side in the third quadrant, sine will be negative, cosine will be negative, and tangent will be positive. We can also say what will be true about the reciprocal functions. Let's go back and find the reciprocal function values for theta. Very simply, all we have to do is just look at the ones we got and flip them upside down. So cosecant of theta is going to be the square root of 29 over 5, negative 5, but I'm going to put the negative in front of the fraction because that just looks better. And then secant theta is going to be square root of 29 over negative 2. And again, I'm going to put that negative sign in front of the fraction for better notation. And then cotangent theta is just the reciprocal of tangent theta, and so it'll be 2/5. As you can imagine, cosecant will always have the same sign as sine. It'll be negative in the third quadrant. Secant theta will always be negative in the third quadrant because cosine is negative. And cotangent in the third quadrant will always be positive. So when you're in the first quadrant, x is positive, y is positive, so your triangle sides are both positive, and which means that all the trig functions are going to have a positive value in the first quadrant. In the second quadrant, x is negative. Cosine will end up being negative because cosine involves the adjacent side, which is the x-coordinate. And so cosine and therefore secant end up being negative in the second quadrant. Tangent is also negative because you've got a positive side, the y-coordinate of your triangle, and you've got a negative side, the x-coordinate of your triangle, and so tangent and cotangent end up being negative. Sine and cosecant stay positive in the second quadrant because you're dealing with the y-coordinate there, because the opposite side, and sine is opposite over hypotenuse, is positive. So positive over the hypotenuse, which is always positive, that's positive. So in the second quadrant, what you need to remember, and you don't actually have to memorize it, you can see it, it's quite clear, that sine and cosecant are positive, but tangent and cotangent and their reciprocal functions are going to be negative. In the third quadrant, like we just saw, tangent and cotangent are both positive because the sides of the triangle now are negative. So the x is negative, the y is negative, and so sine ends up being negative, cosine ends up being negative, and cosecant and secant both negative, but tangent and cotangent end up being a negative over negative, which is a positive. So in the third quadrant, tangent and cotangent are positive. In the fourth quadrant, cosine and secant are positive because the x-coordinate is positive, the y-coordinate is negative, and you associate the x-coordinate with cosine because it is the adjacent side to our angle that we're going to have in the fourth quadrant. So positive, cosine and secant, everything else negative in the fourth quadrant. Okay, so I talked about reference angles. The reference angle for an angle theta is the acute angle, which we call theta prime, formed by the terminal side of theta and the horizontal axis. So if theta is 315, we're starting at 0 degrees and we're rotating counterclockwise, 90, 180, 270, and we keep going to 315. Okay, so our theta prime, our reference angle, is going to be this angle right here. It's the angle between the terminal side of this angle theta and the x-axis. So this angle right here is theta prime. Our reference angle, which is an acute angle that is related to the obtuse angle we're dealing with. So how do we figure out what that is? Well, here you're going around 315. Question is, how much further would you have to go to get to 360? Because that's what theta prime is. And to figure that out, all you have to do is say 360 minus 315. And that's going to give you 45 degrees. And that's what this angle is. It's 45 degrees because that is how far you would need to go to get to 360 after going 315. So the reference angle for 315 is 45 degrees. Negative 195, the negative sign tells me go in the clockwise direction. So that negative sign in front of the angle is just about direction. So don't go counterclockwise, go clockwise. Start at 0, just like normal, and we would rotate, this time clockwise, 195 degrees. So we're going 180 and more than that. And how much more than that is pretty clear that it's going to be 15, and that's going to be the reference angle. So your angle is 195. Your terminal side is there in the second quadrant. Getting to 180 is this. How much more? That's going to be 15, which is just 195 minus 180, because you don't want the 180 part of it. You just want the little part. Okay, if we look at theta equals 3.5, that's a little bit confusing at first because what is it? Well, it's in radians. If it doesn't have a degree sign, it's radians. So 3.5 radians, what is that? We know that pi radians is 3.14. So pi radians is about 3.14, so that's a little bit less than theta. And then say, so that's a little bit less than 3.5 radians, so you probably think maybe we're in the third quadrant with theta equals 3.5, and that's probably true. But just to be sure, we'll look at 3 pi over 2 radians, which is 270, and see what that is. So 3 times pi over 2 is about 4.7 radians. So that's about 4.7. So, right, theta equals 3.5 must be in the third quadrant because it's between pi and 3 pi over 2. So we don't know exactly where it is, but we can just draw something there. And whatever it is, this is going to be the reference angle for theta equals 3.5. This is going to be theta prime. And to figure out what that is, you just have to remember that in the third quadrant, if you are going around in the third quadrant to this arrow here, you're going 180 and then a little bit more, and that little bit more is theta prime. So to figure that out, we know that this whole angle, starting at 0 all the way around here, is 3.5 radians. So we don't want the 180 degrees up here. We just want the angle down there in the third quadrant. So we want to get rid of all that. So that's going to be 3.5 radians minus pi radians, because 180 is pi. If we get rid of those radians, we'll have just the little angle theta prime. So 3.5 minus pi, if we were going to estimate or approximate that value, it would be about 0.36 radians. So that one's a little bit trickier. So 25 pi over 4, that's a big number. Remember that every time you spin around the circle, you go 2 pi radians. Well, 25 pi over 4 is how many radians? Well, if we were to write this as a mixed number, 4 goes into 25 6 times with 1 left over, so this would be 6 1/4 pi radians. Every 2 pi is 1 time around the circle. So if I go 1 time around the circle, counterclockwise, because it's positive, that's 2 pi. So 2 pi. And then if I go around again, that's another 2 pi. So 2 pi. And then if I go around again, that's 6 pi. So 2 pi plus 2 pi plus 2 pi, that's 6 pi. I have 1/4 pi more to go. So pi over 4 more to go. And pi over 4 is 45 degrees. So I end up here for my terminal side. So the reference angle, theta prime, for my theta, which is 25 pi over 4, is just pi over 4, because it is the angle between the terminal side of this angle and the x-axis. So that is pi over 4.